Solving compound inequalities. What if you're given a compound inequality and are asked to solve it? If given an inequality that has an intersection, such as 4 is less than or equal to x plus 2, which is less than or equal to 8, break it into two inequalities and add to the inequalities. So 4 is less than or equal to x plus 2, and x plus 2 is less than or equal to 8. Each inequality is then solved and can be graphed. If you're given an inequality that does not have an intersection, such as this, solve each one separately, as this requires an OR statement. Then graph the union of the two inequalities. Let's solve this compound inequality. First, let's write it as two separate inequalities, and then we're going to solve each one for x using the rules of algebra. So we want x by itself, so we're going to subtract 2 from both sides, and we get 2 is less than or equal to x. Over here, we're also going to subtract 2 from both sides, and we get x is less than or equal to 6. So where are both of these things true? Right here, between 2 and 6, including 2 and 6. This can also be solved without separating the two inequalities. Just perform the same operation by subtracting 2 from each of the three parts of the compound inequality. So because we have x plus 2 here, just subtract 2 from everywhere, and we get 2 is less than or equal to x, which is less than or equal to 6. Solve this compound inequality. 2 plus r is less than 12, or r plus 5 is greater than 19. Solve each one separately, but since this is an OR statement, graph their union as they don't intersect. So here we're going to subtract 2 from both sides, and we get r is less than 10, shown here. Then over here we're going to subtract 5 from both sides and have r is greater than 14. Right there. Solve this inequality and graph it. Alright, so we can go ahead and split this up into two inequalities, although you don't have to. You can just add 10 to all three portions, and then we get 1 is less than x is less than 15. So we draw an open circle on 1, an open circle on 15, and draw a line between them. Solve this inequality and graph it. This is an OR compound inequality, so we're going to solve each individual inequality separately. So here we divide both sides by 7, we get x is greater than or equal to 3, which is shown here. In this one, we divide both sides by 2, and we get x is less than or equal to negative 1. So we have a closed circle on negative 1 with an ray that way. We graph their union as there's no intersection of the solution sets. Solve and graph the solution set. Alright, so here I'm going to rewrite this up here, and then I'm going to solve it all at once. Okay, so the first thing I'm going to do is add 6 to all three sections. So negative 18 plus 6 is negative 12. 3x and less than or equal to negative 3 plus 6 is 3. Then we're going to divide each part by 3. And that gives us negative 4 is less than x is less than or equal to 1. So negative 4 is going to get an open circle. 1 is going to get a solid circle. And we're going to be between those values. So we connect them like that. Negative 5x plus 2 is greater than 27, or x minus 3 is greater than 2. Alright, so here we're going to subtract 2 from both sides. We get negative 5x is greater than 25. Then we divide both sides by negative 5, which is going to flip the inequality. So x is less than negative 5. All right, so negative 5, and we're going to go less than. And then here we get add 3 to both sides, and we get x is greater than 5. Open circle with a ray. So this one can go like that. And there's our solution. Here is the official solution. X is less than negative 5, or x is greater than 5. Okay, so I'm going to add 6 to both sides for this first inequality, and I'm going to rewrite it over here. Negative 2x is greater than 10. Then we divide both sides by negative 2, which will flip the inequality. x is less than negative 5. Okay, so that ray goes that way. Here, we're just going to subtract 5 from both sides. So we get or x is greater than 3. So 3 with a ray that way. All right, I'm going to solve this one all at the same time. First, I subtract 4 from all 3 parts. We get negative 10 is less than or equal to 2x is less than 6. Then we're going to divide all 3 parts by 2. We get negative 5 is less than or equal to x is less than 3. So negative 5 gets a solid circle, and, negative 5 gets a solid circle, 3 gets an open circle, and we're going to connect them with a line, just like that. And here's the solution. Negative 5 is less than or equal to x, which is less than 3.